of us. Okay, very good. Thank you very much for joining us today, everyone. This is another session of Meet the Gurus. We have the pleasure of having Bhavuk Chawla here. Bhavuk, welcome.
Thank you so much, Paul,
Okay, great to
for
see
having
you.
me.
Yeah, appreciate the time as well. As many of you know, Meet the Gurus is dedicated to technology, business, and entrepreneurship, and the way these fields have powerfully converged over the past years. We're sponsored by Starweaver, and it's dedicated to spreading knowledge and ideas. And today's knowledge and idea is all going to be about machine learning and Google. And we have a guru here to talk about that, who's been there, done that for many years. Bavuk, how did you get into the Google universe, and how did you get into machine learning and data science overall?
That's a very good question, actually, Paul. So I need to go back 10 years back when I was working for a company called Pitney Bowes. So I was working on one of the use cases wherein I applied k-means clustering to solve a business problem. So it started with that machine learning problem. And after that, this field actually excited me a lot. And I started delving deeper into this particular area, this particular technology.
It's
And
interesting.
then later on, when Google Cloud started to become popular,
Yep.
then I started to clear the certifications related to Google Cloud Platform. For example, I did my data engineering certification in 2017.
Mm-hmm.
So that was in beta phase. So I was first few people who cleared that certification when very little information was available on internet.
Yep.
Same thing happened with me. Like when I cleared my machine learning engineer certification, that was also in beta phase
Mm-hmm.
when there was hardly any information available about this certification on internet.
Mm-hmm.
So when Google actually started to launch these certifications, I started to clear these certifications.
Mm-hmm.
So that's how my journey started.
It's interesting. You know, Pitney Bowes, for those of you who don't know, is a huge American company, but was best known back in the day, as they say, for making machines that were postage machines. You know, so they literally, I've actually been up their headquarters in Connecticut, I think it is, and Stanford, I'm pretty sure it's in Stanford. And yeah, it was back in the day when but they became an information services business, right? And so, you know, it's a company that makes the machine that, like IBM, used to make business machines, international business machines, realized we're not just a machine company, we're an information and in a case, data science company as well.
And they acquired a lot of location intelligence related companies. So there where I started my journey in location intelligence domain. And there only I applied this k-means clustering, very first algorithm. It was 10 years back. I was a solution architect working for that company.
It's interesting, you know, being old enough to have seen, you know, machines turn into knowledge and knowledge turn into services. It's
Yeah.
fascinating to see how information was at the core of it all, right? And so you know, data is everywhere, but you know, information is not. Filtering it and synthesizing it into something that's interesting and usable is basically is that a fair distillation of what machine learning does? Takes data, turns it into something useful.
I would like to augment few more things here. One thing is like historical data analysis, which is not actually machine learning, but that is more like data analysis through maybe many people do it through SQL, many people do it through Python, pandas, but that is more like conventional data analysis, analyzing the past information. But right now, when we talk about machine learning, we are predicting future. So it is more about predictive analytics or prescriptive analytics. So many areas will come under that machine learning. So I will talk about this domain more as we move into the presentation mode.
Yeah, and it's fascinating that you know, it's evolved, right? It's evolved as a concept. I mean, keeps evolving. People sort of think that's what it is, and obviously in the information businesses that we're in, as you get more information, it changes, right? So, what is predicting the future? What is predicting? What are the algorithms that help you understand?
Yeah.
You know, things that I've been fascinated. There's great books by Ray Kurzweil who talks about this, you know, the brain and information, and I think it's all about and Google has been at the hub of this, right? I mean, if you'd say
Yeah.
where's Google's strength, when people say, you know, what is search,
Yeah.
it's
Yeah.
it's
Yeah.
accessing these algorithms, right?
Yeah. So machine learning is all about learning from data, and Google has the most data. So it's not the best algorithm that wins, but the algorithm having the most data wins overall. So that's the fact.
No, it's absolutely true because, you know, I'm always amazed, and I have Alexa in my house in various places, several of them, and you ask Alexa a question, it's usually, I'm not sure about that right now. And then
Yeah.
and friends who are not in the technology businesses always say, like, why does Alexa not get it right? And I can ask my phone, Google, and Google
Yeah.
gets it right all the time. And not only that, by the way, as I said that, Google, my phone opened up and wanted me to. So absolutely, what is it, 60,000 searches per second? I think are being done on Google.
Yeah, so it's huge, and that's why Google is the leader in terms of like artificial intelligence and machine learning. So I will talk more about it once we are going through a structured way of understanding how to clear the certification. Then I will present like why Google Cloud, why we are even discussing about Google, why not other platforms. So I will talk about that
No, but it's
aspect as
volumes
well.
of data. I mean, I know that a lot of
Yeah,
people who they're people at the Allen Institute and other places where artificial intelligence is strong. I mean,
yeah,
it's great concept to accumulate data, but when you have data, you have the
yeah.
ability, correct, to analyze it, to evaluate it, to determine what it means, and then what you can intuit or what you can conclude from that.
Absolutely. Yeah. So what's the context behind the data?
Mm-hmm.
So when we talk about huge data, then we are also talking about variance in data. So do we have sufficient number of examples to
Mm-hmm.
train our machine learning model? And
Mm-hmm.
Google has that variety.
Mm-hmm.
So that's why if you ask random questions from Google Home, then it gives very nice results as compared to Alexa or Siri. So they are not good at it.
Right.
So you have mentioned it very nicely, like how you as a user you can see
Right.
that difference.
No, and you're going to talk about and show us how we get data sets because obviously on our platform and elsewhere, you can on Kaggle and other places that Google, for example,
Yeah,
hosts. You need data. So in order to be a data scientist, in order to apply machine learning, you need to know how to get data, where to get data, what data is useful, what data is, and you'll talk about that. But why don't you jump into your presentation? I know you've got the great way of sort of synthesizing this for people, and we'll talk through it from there.
absolutely.
Just let me know when you're sharing your
And
screen.
I'm sharing my screen. Once you are able to
There we
see it,
go.
just
Perfect. Yeah, we can see it. Go ahead, please.
great, great. So I will quickly introduce myself. My name is Bhavuk Chawla, and I have more than 17 years of experience working in Google Cloud Platform for last more than 5 years now. I cleared my data engineer certification in 2017, and after that, I did this couple of times, like more than after every 2 years, I have to renew the certification. And I did my Google Machine Learning Engineer certification in October 2020. So that was a beta phase when I did clear my certification. So now the goal of this webinar is to ensure that you go to the next level, the participants who are actually joining remotely, and then they are understanding how to clear the certification. So the goal is to ensure that you also able to get this certificate. So this is how it will look like. The certificate, the professional machine learning engineer certificate, and it's a big achievement. It's from my perspective, because otherwise also, if you see, this is one of the most challenging certification in the cloud world, or maybe in the technology world overall, I would say, because the complexity of this certification is way more higher than other certifications that I have done. I have done more than 25 certifications, but I consider this certification as like one of the most complex certifications compared to other certifications that I am having. And if I see overall in technology world, this particular certification is one of the most coveted certification, and it requires really a lot of hard work to gain it. So that's the purpose today, to share my knowledge, and I would like you to go through this process and achieve this certification.
Fantastic.
Great, thank you. So overall, this is the agenda today. So we want to look into who is a machine learning engineer, and the typical machine learning pipeline. We will be also looking into the Google Cloud Platform, why we are even discussing about that, and then we are moving into machine learning pipeline on GCP. And then we will be looking into certification objectives and what specific areas we need to focus to clear the certification. And I will be sharing a lot of additional links with you so that you have a lot of things as next step after you drop off from this webinar. So it's not like end of something, it is just the beginning of your learning journey if you're starting to prepare for this certification. Okay, great. So now question is, who is a machine learning engineer? So usually when I interact like over Zoom, so we have people unmuting and then asking or maybe sharing their thoughts about this particular, like I usually keep it like a question answer way, but right now I will answer, and I will just encourage others also to share their like perspectives over the chat. So that is one of the ways through which we can interact. And Paul, you can assist me in
A-
letting me know like the chat
Absolutely.
message.
We're monitoring questions now.
Great. Thank you so much, Paul. So who is a machine learning engineer? So very first thing is many people get confused data scientist versus machine learning engineer versus data analyst. There are so many titles. So please understand like the responsibilities are very much like different in most of the organizations. You will see there is a different department for engineering. There is a different department for research. So you will find most of the organizations, they have this kind of segregation, but some organizations which are like startups maybe having very little distinction between data scientist role and machine learning engineer role. But I would consider it as an enterprise, like you are coming from an enterprise environment, and there you will find like engineering is more closer to the production environment. So when I say more closer to the production environment, then engineers are responsible for building up the things. For example, civil engineers, they are responsible for building up the bridges, right? So similarly, we have software engineers who are responsible for building the software. So machine learning engineer is responsible for building machine learning pipelines and scaling those machine learning pipelines. So we will be looking into various aspects. And data scientists, they are more into research. You know, scientists are working in a lab environment. They are not closer to the production environment. So they are experimenting and they are prototyping with Python, R, SAS, RapidMiner, or there are so many technologies through which data scientists can perform experiments. So data scientists are more from like a combination of business knowledge, statistical skills, and uh, the overall software engineering skills. So it's like a Venn diagram you must have seen otherwise also. So machine learning engineer specifically is the person who is responsible for scaling the machine learning models, deploying the machine learning models in production, how to ensure that the different versions of machine learning models are deployed, and we can perform some A/B testing. We can monitor these machine learning models. We can choose the right machine learning model. Are we deploying this machine learning model on the edge, or are we deploying this machine learning model on the cloud? Are we looking for some real-time training or real-time predictions, or are we looking for batch predictions or batch training? So depending on various parameters, the machine learning engineer will be coming into picture. I will give you a very simple example. So let's say this is like non-COVID time and you are booking Uber and there are a lot of transactions going on. Like so many people are trying to book taxi, or like through Uber cab, you are trying to book a cab through Uber application. So the Uber application has many machine learning models. So one of the machine learning model is responsible for showing you the taxi fare, like the trip fare, how much it will cost from one location to another location, from your source to destination, how much it will cost. So sometimes it happens that the machine learning model is not able to display you the cost of the trip. And then we say that, okay, let's skip that part and let's move to the next step. So then it will show you a message. Are you okay to proceed further without knowing the trip cost? So sometimes we get this kind of message, but people will not be happy when we don't get the trip price, trip cost. Because right now, maybe the service which is responsible for providing us the trip cost is too much busy, because there are so many concurrent requests going to that service. So machine learning engineer is responsible for ensuring that we have the right parameters, the evaluation metrics that we are having in the production. So for example, throughput, the queries per second that our machine learning model is able to handle in production. So you can expect in Uber, when there is a peak hour, then you can expect millions of requests are coming to Uber service, which is responsible for giving the trip price, the trip cost, right? So this is the basically one simple example which you can relate, like how many queries per second. So machine learning engineer will be looking into that. How much time it took to get that response, that is latency, right? So one thing is throughput, another one is latency. So there are so many other factors that machine learning engineer will be monitoring. when machine learning model is deployed. So this is a high level summary about who is a machine learning model, machine learning engineer. So if you are having any questions, feel free to ask. So Paul, does it help? Like, are you able to relate?
Yeah,
I
I'm
know you
relating.
are.
Don't worry. We're just we're listening. Everyone's very interested.
Great, great, great. So from Google perspective, this is the definition of a machine learning engineer. And you can see like the person who is responsible for designing, building, and productionizing the machine learning models. So as I mentioned, like engineers are working closer to the production environment. So machine learning engineer is also working closer to the production environment and ensuring that the various parameters on which we are monitoring the model, they are as per the expectations, right? So I gave some simple examples, trying to keep the thing simple rather than going into too much technical details. But overall, this is the idea. And the machine learning engineer is responsible for the entire ML pipeline, and the person is responsible for framing the machine learning problem, architecting machine learning solutions, preparing and processing the data, developing machine learning models, orchestrating machine learning pipelines, monitoring those pipelines, taking care of model deployment, serving the machine learning models, optimizing the overall machine learning model performance, and then maintaining the machine learning model. So this is the official definition of a machine learning engineer from the Google Cloud certification guide itself. But I have given my flavor also to this particular definition. I hope you got some idea about ML engineer, who is that guy, and how it is the person is different from data scientist. So yeah, data scientist is more into storytelling, more into business, more into like statistics, and the data scientist is having the vision of the project from business perspective, and also doing modeling and trying out various models, doing quick prototyping through different technologies. So this is what data scientists usually do. They are far away from production, but machine learning engineer is closer to the production environment. Yeah. But some companies, they allow data scientists to deploy machine learning model. So it's like asking chef to serve to the customer. So you can say like it's not the best thing to do, because machine learning engineers, they have to take care of so many aspects that as an engineer we have to think about scaling, deploying, serving, and many other things. Yeah. So now the question is why we are even talking about this particular certification, machine learning engineer certification. So, like Google Cloud certification, they are in high demand, and uh, Google is the leader when it comes to machine learning and artificial intelligence, right? So this is one of the main reasons. And, Google brain team actually created TensorFlow, and Google actually released so many white papers. And because of those white papers, there were a lot of technologies created. For example, in open source world itself, Hadoop was inspired by a Google white paper. And within Hadoop, there are many technologies like HDFS inspired by GFS white paper, and MapReduce inspired by Google MapReduce white paper. And there are so many other technologies. So when I say Google certification, so Google is in like forefront of innovation. So many white papers, so many patents Google is having. Google got the dropout patent. Like this, another very important technique in case of neural network regularization technique. So Google got that patent as well. So there are so many patents that Google is having, and when we actually complete this certification, then definitely it will add a lot of authenticity to your profile, the kind of work that you have done, because this certification is one of the most coveted certification, and it will help you in your professional career. So coming to the certification, when you appear for the certification, which all things you need to take care. For example, like this is a 2-hour certification, but when I appeared for this certification, it was 4-hour certification. I appeared for this certification when it was in beta phase. It was not like it was not very well organized at the time. It's like beta phase is for testing. So it was for ensuring that people understand the questions and they are able to answer the questions. So after that, Google fixed the duration to 2 hours. So now when you appear for this certification, it will be of 2 hours rather than 4 hours. So in my case, it was 4-hour certification. It was in beta phase, and you can expect like 60 questions in your exam. and each question will be having a unique scenario. So it's not like a case study that you need to go through and then it's like you are answering questions like maybe 10 questions together for a particular case study. It's not like that. The pattern is not like that. So pattern in the certification will be like each question will be unique and there will be scenario for that particular question, and it will be matching with the real world problems that you would be dealing as a machine learning engineer, right? So in case you are interested to know what kind of problems that you will be getting in the exam, so I would encourage you to go to the Google Cloud exam guide, and there you will find there are sample questions given, right? So there are like, I think more than 40, I think to be specific, like 14 questions are given in the guide, Google Cloud exam guide, and then you can get to know like what kind of questions you will get. So overall, this is like $200, and along with some additional taxes, and you can register for this exam. You can appear for this exam online, or you can appear for this exam in an exam center. So you can get the list of exam center through this link, and you can find this very easily on the Google Cloud website itself. So overall, the technical aspects, we are more keen and interested in this particular webinar. So I will be focusing on these aspects. So very first area that we are having here is the framing the machine learning problem. And how will you actually frame that problem, and how you will identify this is a machine learning problem, and how you will translate the business problems into machine learning problems, and how you will define the success factors and the failure of the project. Like when you will say that the project is successful, is it like 99% accuracy or 99.99% accuracy? So this is like business success criteria that we will be defining in the very beginning of the project itself when we implement. So it is expecting, like the very first section is expecting you to know how to frame the machine learning problems. So what are the risks of the machine learning solutions that we are proposing? So, there are so many things that I want to share that you need to go through. So this is the page that you can go through, wherein you will find the official exam guide. And I will be sharing additional links that will help you in cracking the exam very easily. For example, very first thing is machine learning glossary. So if you are coming from machine learning background, you will find that a lot of things you are already familiar with, but many people come from GCP background or cloud background and they are not familiar with machine learning. So in that case, I would encourage you to please go through this glossary and understand like the important terms that we are having. So that will basically set the stage, or it will lay the foundation for preparing for this exam. So this is the very first step that I would recommend, to go through this particular glossary and understand which all terms we are having in ML. So once you are done with this, like you understand the terms and you understand like what exactly is bucketing, what exactly is categorical data, what exactly is checkpoint, and many other interesting terms that we are having, cloud TPUs and many other things. So then I would encourage you to go to this particular link, and here you will understand how do we frame a problem, machine learning problem. How do we frame a machine learning problem? So how do we decide what is the ideal outcome, right? And what is the success metric and what is the failure metric, right? How will you say that my project is successful and how my project is a failure, right? So you can,
before you go on, I mean that's a fascinating. Obviously, this is quite interesting to me. I was going to ask you another question, or have another question that came in, but talk about that in more depth. How do you define success? I mean, that's kind of in a machine learning world, it's probably different than we define it in life.
absolutely, yeah. So very much different. So sometimes like it is all driven by business requirements. So you have to freeze that from the various stakeholders. You have to define, let's say you are doing fraud detection. So when you are doing fraud detection, so do you consider your project to be successful when 99% of the frauds are detected, or when your 99.9999% of frauds are detected? So what is your success factor? So you have to get the buy-in from the business, freeze those requirements in the very beginning itself, and then you target to solve the problem, and considering those constraints in mind, or those factors in mind before you proceed further. So this is like a very simple example that I gave, but we have to freeze those metrics. Accuracy is not the right metric. There are so many other interesting metrics, but just to keep it simple, I try to explain in that manner, like how do we define the success or failure of a project.
That's actually what I was thinking of in the context of that is also how it relates to the creation of the use case at the front end, right? It sort of relates very tightly to the use case, because if the use case is not clear and the business people haven't, or you haven't captured the business person's goal and success, then you really it's a very agile concept, right? You don't know what success is, you can't say we're done.
Absolutely. And like there are 5 interesting questions in data science on a very high level. So one question is how many or how much. Let's say you are predicting property price. So if you are basically targeting how many or how much, so this is a problem called regression problem in machine learning. So you are predicting what will be the property price in Boston area after COVID. So if you are planning to work on a machine learning problem like this is a data science problem, but I am just trying to relate because machine learning is also subdomain of data science only. So very first question is how many or how much. So for example, the property prices, this is regression problem. Second problem, maybe you are doing some classification. So you are classifying spam emails or ham emails, right? So normal emails or spam emails. So this is a classification problem, like you are segregating cat pictures and maybe not a cat. So classification problem, right? So third problem can be like you are grouping your customers. So you know that our customers, some customers are going online and they are price sensitive customers. But the customers who are visiting stores, they are brand sensitive customers. So you can group your customers, you can cluster your customers together. This is like a clustering problem. And then we have another problem, which is called, is this something very different or weird, or which is like anomaly detection, right? So this is another problem that we can solve through the various machine learning algorithms, right? And then we have, what should I do now? This is like recommendation engine. Which book should I buy, or which product should I buy? There are millions of products on Amazon. Even I don't know what product I will like, but Amazon knows that. How? Because they are applying machine learning behind the scenes, and then they are able to show the recommendations, right? And the model is also rendering the results, like very fresh results. That means like based on the current buying behavior, it is able to render me the recommendations which actually map to the recent purchases. So that is like model freshness. So how fresh is the model, right? So they are retraining the machine learning models behind the scene and rendering the results so well, right? So that's why people are able to monetize, like Amazon and so many other companies are able to monetize that user behavior. So I hope you are able to get like what kind of business problems that can be solved through machine learning, Paul.
Yeah, you've presented in innumerable ways and slices of looking at the problem. It's great. It's very, very helpful to everyone, I think.
Great. Thank you so much for asking questions, because when you ask questions, then it is like much more engaging and I can share different perspectives. I was not having any plan to talk about so many things, but since you asked this, so I had to like share, and I'm just thinking like we are having only a minute left for this webinar, but I will be taking maybe another
That's
30
it. You can
minutes.
keep going. There's no cutoff necessarily. We usually do 30 minutes, but we've done hour-long webinars as well. So whatever's good for you.
Thank you so much, Paul. So this is one area that you can actually explore, and you will find there are some interesting sections like formulating a problem, and apart from that, ML mindset, how to change your mindset as a machine learning engineer mindset, right? Or how to identify which problems are good for machine learning, right? So what are the very hard problems for machine learning? So just explore it. So the idea of this webinar is to give you the path. So you need to actually follow the things that I am recommending, because these things actually helped in my certification, and I was able to clear the certification. And I'm glad to share this information with you all so that you can also go to the next level. That's the only goal of this webinar. So now we are having another perspective, which is called fairness. And if you see, I'm also mapping with the certification objectives that we are having, identifying the risk and feasibility of machine learning solutions. So you will find like when we are implementing machine learning problems, right? And then there are a lot of different types of biases. So please understand this bias is not bias versus variance trade-off in machine learning. This is a different bias. And within that, you have reporting bias, right? So many people don't even report, right? So they they don't even report. Like when you are taking survey of, like there is a very famous problem related to the U.S. election, and like that one is more related to sampling bias. So in 1956. There was a data science problem applied to predict who will win the election. But the survey was done only to those people who were having the landline phones in 1956. So there were very few people, privileged people, who were having landline phones during that time, right? So that means this is like a sampling problem. This is called sampling bias in machine learning. Similarly, we have reporting bias. People don't report certain aspects. They don't reveal certain aspects. So if you are having reporting bias or sampling bias or automation bias, sometimes we are hesitating in acquiring data from those sources which are difficult to automate. So we are not even going to those data sources from where we will have challenge retrieving data. So this is called automation bias, right? So sometimes in company, we have different departments and you don't have a good relationship with another department head, and then you don't want to acquire data from that particular department. That is also happening in machine learning projects, right? So that is automation bias. So there are so many challenges. So these challenges will actually impact your results in machine learning. So what are the issues? What are the problems that you can encounter? So that's why we say that there is there are types of biases, and these are reporting bias, automation bias, selection bias. There are many other different types of biases. So please have a look. This will help you in adding knowledge for clearing the certification. So
one of the things I would comment on is that obviously machine learning has, if you're good at statistics, you know, you'll certainly, I imagine, do much better in the field, but also these are rational. These are not abstractions. These are not, you know, highfalutin, you know, notions. These are very practical things which anyone can understand, the types of bias that you just described, for example.
Yeah, 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 yeah.
Okay, that's great.
So if you know these biases are there, then you will be able to take care of it when you are actually applying it in real world. So it's more a pragmatic approach. When you are labeling something, then you say that there is a labeling bias. Maybe different people have a different perspective to look at the things. And maybe someone is saying that even the zebra crossing is also part of the road. And some people are labeling like, no, this is not part of the road. So depends like what is the perspective of the person who is labeling. So there are biases at different stages, and we need to take care of it at different levels. Our preconceived notions should not become part of our ML model, because ML model is representing a real world scenario, and we should not be in that trap. So we need to be careful. This is more like a practical trip, more like a practical tip, but also it is going to help you in certification to at least understand these aspects and take care of these. In certification, there will not be like direct questions around this, but it will be more like scenarios. And in those scenarios, if you have this understanding, then you will be able to answer the questions very well. So now we have architecting machine learning solutions. So we have to think as an architect. We have to think as an engineer. You have to think about security. You have to think about like overall how the IAM roles are being managed on Google Cloud Platform, how the solution will be architected, and how the overall like the pipeline will be created, and how the components will integrate together, how we are scaling that particular pipeline. So we have to think about maybe many aspects related to not just security, but also thinking about the overall solutioning aspect, overall architecture aspect of the machine learning solution. So you have to think about the data connections, the data sources that we are having. Do we have on-prem data sources? Do we have some proprietary formats, or do we have some cloud-based sources? So you have to think about optimizing the overall pipeline and avoiding any ad hoc things that we are having. So it should be a standard way of implementing machine learning. So you have to architect solution in a manner so that you have a repeatable and it's like a standard way of doing things, so that the errors can be avoided or the problems can be avoided, so that we focus on more related to the proper architecture of the machine learning solution. Yeah. So apart from that, we should also think about the hardware components like TPUs, GPUs, and many other things that Google offers, right? So we need to be aware about those particular areas, right? Apart from that, you have to think about data preparation, processing systems, because making data useful for machine learning is very important area. So if you are not cleaning the data properly, then you don't expect good results from machine learning. So it's like teaching a machine is like teaching a kid. So if you are showing proper data to the kid or showing the right information to the machine, or if you are sending the right data to the machines, then only the machines will learn well. So this is like you are creating these data pipelines, and these data pipelines you are exploring the data. You are making that data useful for machine learning. For example, you are normalizing the data. You are removing the missing values, or maybe handling the missing values, or you are taking care of outliers. You are taking care of imbalanced data. You are taking care of multicollinearity. So you are taking care of so many things here, and then feature engineering will take months to actually implement this particular thing. So I would say this area, you will be applying many technologies. If you know pandas, that's good, but you should think about Google Cloud solutions also. For example, data flow, knowledge of data flow will help a lot, and how data flow is taking care of batch data as well as near real-time data, streaming data. So how data flow is taking care of that. From engineering point of view, we should know all these aspects: data flow, BigQuery, and many other areas. So I will talk about the specific areas that we should know. Then we have developing the machine learning models. Yeah, Paul, please go ahead.
Just before you jump in, is feature engineering, maybe helping people understand it, is really having domain knowledge to be able to use that to extract features from the raw data. So whether that's business domain knowledge, or mostly it's related to the business or the subject, whether it's
Absolutely.
virology or whether it's entertainment, the entertainment business, knowing how many people, as they say, put fannies in seats in movie theaters, is domain knowledge.
Yeah, Paul, this is a very good point. Actually, I will elaborate a bit more, and I will add a few more things.
Sure.
Maybe I'll take a few minutes. So feature engineering in very simple terms is simplifying inputs for machine learning models. So when you are showing timestamps to machine learning models, they will take long time. But when you are showing let's say you are an expert of Uber, let's say you are a data scientist at Uber. And when you are a data scientist at Uber, so you know that what is the definition of peak hour? So maybe if you can share, Paul, when is the peak hour in your city? Let's say
typically, be, let's say 4 to 6 o'clock, or maybe depending on a weekend, it might be evenings 5 to 7, or maybe later on, depending on if you're in New York City, it could be 10 o'clock till 2 in the morning if you're going out in parties and things like that.
Very nice. So this definition of peak hours will vary. So if you can create some features from the data, for example, one option is I can pass timestamps directly to my machine learning model, but my machine learning model will fail miserably unless or until I provide lot of data to train, because timestamps are very difficult to understand for humans. So definitely machines will also face difficulty in understanding the timestamps. So better way is to extract the time of the day. Better way is to extract the day of the week, and then based on that create some features. You are a domain expert, you know your city, you know the traffic condition, you are a data scientist at Uber, so you want to give some hints to the machine learning model. So feature engineering is basically focusing on this particular aspect. Based on your domain knowledge, you pick up those features which will be helping machines to learn faster.
So you could go down a rabbit hole. You could go down a rabbit hole really long and hard, and essentially, as you said, the machines will not provide the answer. Or you could ask someone who's lived in Delhi or in Brussels or in New York, and they could say, "Well, it's hard to get a cab at such and such a time." So you've saved a lot of that human intelligence that we've developed through essentially pattern recognition over many, many decades of our lives. A child won't know that, but obviously an adult will, right?
Yeah, absolutely. So it's like feature engineering is helping us in simplifying inputs to the machine learning model to get better performance from the machine learning model. That means the results will be better, the accuracy or whatever performance metric that you are having will be better. Second thing is you can train machines with less amount of data, right? And you will get the results faster. So there are three advantages of having feature engineering in place. And I would love to talk about feature engineering for days, but I don't have time right now.
We
But
will at some point, I'm sure.
yeah, sure. Thank you so much, Paul. So here we have developing machine learning model. So we have to choose a machine learning model, and every model has certain constraints. So which model should I choose when? So there are so many factors that we need to consider before we go for a machine learning model. And then training that machine learning model, testing the machine learning model, and then scaling the machine learning model, serving that machine learning model. So all these aspects are actually part of the certification. I will be delving deeper into these topics, so don't worry about it. Now, apart from that, like how you are actually creating machine learning pipelines. So I'm a big fan of pipelines. So you know water pipelines at home, Paul?
Yes,
Like
of
water
course.
pipelines, what they do? Like they pull out data, they pull out water from the raw sources, and then they clean it. Like you get the fresh, clean, drinkable water from your tap, right? So same thing, these pipelines, the data pipelines, they are retrieving data from raw sources, and then they are cleaning the data, and then they are providing the data which is consumable for machine learning algorithms, or data which is consumable for business intelligence reporting, or maybe some other downstream system, right? So that's the goal of machine learning pipeline, or like data pipeline specifically. And then machine learning pipeline is also like taking care of iteratively we are building the model. I'll show you some interesting pictures that will help you in understanding how the ML pipelines are working. So I have to elaborate it, don't worry about it. So let me go to these aspects. Like all these aspects I will be covering in much more detail now. So how to prepare for this certification. This was just the walkthrough of the exam objectives. Now, in order to prepare for this certification, you will see, like you should understand the overall process. The process is iterative in nature. It's not like sequential process. So in this process, if you see, we are defining the business use case, you're framing the problem, and then you are you are doing the discovery of the use case, and then identifying the right data sources, and you are exploring the data, and after that you are selecting the algorithm, data pipelining, and feature engineering aspects. And feature engineering actually includes feature scaling, feature enrichment, feature extraction, feature selection. There are so many areas within feature engineering. And then building the machine learning model, evaluating the machine learning model, presenting the results, and then there is a plan for deployment, operationalizing the model. So there are so many areas. And then finally, monitoring the model. So this is an iterative approach overall. This is the high level flow that one should understand before attempting this certification. If you are comfortable with all these areas, then we should now talk about another part. So this is typical machine learning pipeline, or the overall in simplified manner. Like this is data acquisition, this is data preparation. You are making data useful for machine learning. After that, you are choosing the machine learning model, and then you are training the machine learning model. You are learning the model parameters, and then after that, evaluating machine learning model. So this is like ensuring before the machine learning model is deployed in production, is it good to go or not? And then model tuning, hyperparameter tuning. So in certification, you should know what are the different hyperparameter tuning strategies and which one to choose when. So all these things you should be aware. Model deployment, and then making predictions from model monitoring and maintaining that model, right? So overall, this is the high level picture about the machine learning pipeline. Now, that was more towards the machine learning, but what about GCP? Because we are talking about machine learning certification of a Google Cloud platform. So machine learning engineer of a Google Cloud platform must understand the various technologies which are involved at different stages in the pipeline. So this is like preparing the data. So there are multiple technologies involved. I don't have time to talk about this, but very quickly, this is more for data analysis, serverless data analysis. This is more for maybe migrating your existing Hadoop and Spark cluster on Google Cloud Platform very easily. You can do that, like it's more like a managed service. And this one serverless, so data flow, you can clean your data, in batch mode and serverless manner. And data prep, it's more UI based, very convenient for business analysts to work with data. And then we have pre-processing, the tools that I just mentioned, AI Hub, where you can discover the data, you can explore the data, you can perform exploratory data analysis, and a lot of other interesting things can be done. And then you can have the AI platform. I will quickly show you the AI platform, how it will look, how it looks like. So this is AI platform Kubeflow pipelines that you can build, and then TFX, TensorFlow extended. So this is another framework which allows us to build pipelines. And then this is AI platform Kubeflow. So overall, this is the holistic perspective around the certification, the areas that you should be comfortable in when you appear for this certification. Yeah. So I may be fast. Just let me know, Paul, if you're
No,
not
you're good.
very
We're still got a few more minutes. Let's try to wrap it up by the top of the hour, which will be about 15 minutes from now. So we'll keep going.
Sure. Sure. So this is overall AI framework on GCP, and it is evolving a lot. A lot of new things are being added. So I would encourage you to be comfortable with various terms which are mentioned in this AI frameworks. You should know like what are the different ways of building machine learning models on Google Cloud Platform. So I have a presentation also, like for Microsoft, I gave that presentation that is like how to use AI in a simple manner. Yeah, so that is there on Microsoft Reactor channel. You can watch that video. So in case you are looking for a link, I can provide you that. But right now I don't have that link handy. But I'm just thinking like that presentation will help you in understanding how to apply artificial intelligence on cloud, even though that presentation is on Microsoft, but that will help you relate concepts in Google Cloud Platform also. So this is the learning path. Maybe on Coursera, you can go through these courses. These are there, but I would like to share the specific areas that will help you in understanding like which topics you need to focus. So from data engineering side of GCP, you should know PubSub, and Gmail service of Google Cloud is based on this PubSub. You can have billions of messages being sent in 1 second. How Gmail is so fast, right? What is the beauty of using Google Cloud Platform? Because there are so many flagship products of Google, and there are billions of users who are using these products, and our workloads are running along with those products. Like Gmail, with Gmail your application is running like in the same data center. So that's the beauty, right? So you are able to get the same power, same same services. Like Gmail is using PubSub, which is like billions of messages you can send in 1 second, and even your application that you are building, you can leverage these kind of capabilities. So cloud storage is another interesting area where like it's based on Colossus file system. And then Bigtable, another interesting area. HBase is inspired with that Bigtable white paper of Google. And then BigQuery, serverless data analysis, data flow, data prep, so many things like data fusion, data studio, data formats, various data formats, Avro, Parquet, ORC. So we should understand these areas. Data engineering side of GCP, because this is a certification where we have engineering aspects also, Google Cloud aspects also, along with machine learning, right? So there are three aspects. If you break down this certification, there are three areas. One is Google Cloud, second thing is machine learning, and third thing is engineering aspect. So I'm talking about engineering aspect. This one is like, again, security, privacy, cloud build, monitoring. From machine learning point of view, you should know the sampling of data, splitting of data, bias variance trade-off, regularization techniques. So what are the different regularization techniques and which one to choose when? So all these areas you should be comfortable. Then knowledge of machine learning will help you, like the regression, is it a classification problem or collaborative filtering or maybe clustering? So you should know all these aspects. Feature engineering techniques, you should know bucketing, you should know binning, and then there are so many other areas within feature engineering. You should know about those areas. Model evaluation metrics. So you should know like precision, recall, AOC score, and there are so many F1 score. You should know all those things. Hyperparameter optimization. There are many areas like many techniques, random search, grid search, Bayesian optimization. You should know all these things. Prediction phase, it can be batch, it can be online. So you can expect some questions on these aspects as well. And then BigQuery machine learning capabilities. You should know what BigQuery machine learning can support, can provide. Apart from that, you should also know how to build your own machine learning model on Google Cloud Platform using TensorFlow. what are the different ways of performing machine learning. So this is like building your own machine learning model, and then auto ML capabilities of Google. And then we have transfer learning, pre-built machine learning model APIs of Google, BigQuery ML, model deployment. It's on cloud or it's on edge. So you should know TensorFlow Lite, model formats, model versioning. So all these areas you should be comfortable. And along with that, in artificial intelligence slash deep learning. So specifically, like overall, we should know the concepts when we are training a machine learning model or deep learning model. Then what is involved, like epoch, batch size, learning rate, optimizer, activation function. So all these areas we should be familiar and comfortable. What are the trade-offs of choosing one over the other? So all these things we should know. So I'll take 5-10 minutes more. Yeah. So these are like various areas that you should know, like TensorFlow ecosystem. Apart from that, like deep learning architectures, chatbots, conversational AI, dialog flow, explainable AI. And then we have many tools, what if tool, Katib, Kubeflow, TensorFlow, there are many tools. So I want to show you very quickly the links that will help you. So this is a white paper which actually talks about the problem with AI is not AI. That means the problem is more around the ML code is very little, but there are so many areas which are actually problematic areas for us. So as a machine learning engineer, you should know all these areas and how you will handle the areas around ML code, right? So this is another interesting part, like what is ML ops and how it is different from DevOps. So I would encourage you to please go through this link and understand like overall how this is working. Apart from that, there is another one. This link will tell you like AI and machine learning products of Google Cloud. And then we have how to study for this. Maybe you can go through this particular link where you will find various courses. For example, we have course. There is a course which is called Crash Course in Machine Learning. So as a starting point, you can start with this particular course, Machine Learning Crash Course, and it will give you some understanding about the TensorFlow APIs, regularization technique, and basics of neural network. And if you want to practice, then I would encourage you to explore the machine learning examples in Colab as well as in the Google AI platform. We have many pre-built examples in the AI platform. If you just create your trial account in GCP, and then if you explore AI platform, you will find I've created some videos also on my YouTube channel where I explained the AI platform. Then dataset search. This was one of the areas that Paul mentioned. How do we search for dataset? So you can search for, let's say, telecom data. So you'll get a lot of data for telecom. For example, COVID dataset. So you will see like there are a lot of data sets for COVID. So apart from Kaggle, you also have this dataset search where you can search for different data sets depending on the domain in which you are interested in. And then this link is very interesting, which is talking about the best practices of performance and cost optimization for machine learning. So please go through this and understand how the ML is working on GCP, how data flow is being used, how Apache Beam is being used. And then next one is like Kubeflow pipelines, TensorFlow extended, and Cloud Build. So this is also another interesting area. And then this part is also another very important area, which is like best practices of machine learning engineering. So you can expect some questions. Like there will not be straightforward questions, but there will be scenario-based questions. But if you understand these areas, then it is going to help you a lot. So I would encourage you to please go through this best practices of machine learning. And then this is TensorFlow extended on this. If you want to practice, this is like taxi fare prediction. So example that I was talking about, the peak hour. So you can apply those feature engineering techniques here. And there are some other interesting parts like Kubeflow pipelines. You can build your own cloud native pipelines. There's another area which is like auto ML. And then we have minimizing the real-time prediction serving latency in machine learning. So similarly, we have what if tool, which is going to help you in understanding how the model is working, right? So you can understand it's not a black box. You can understand by changing the parameters. So here we have fairness indicators. And then, okay, so this is fine. Okay, so these are the videos that you can go through. Okay, so this is the sensitive data with machine learning data set. So I would encourage you to go through this as well. So this was very quick. I understand it's not easy to talk about a certification which is having more than like 50 areas, more than 50 technologies to cover. So I tried my level best to give you
You've,
maximum things in just like 1 hour.
as I always say, I'm careful about how I say this in a humorous way. It's like they say, how do you eat the elephant? One bite at a time. To my Indian friends, I
Yeah.
always say we don't eat elephants, but but it's such an enormous package of knowledge. But it is really about creating a journey, creating pathways, which we have on our platform, obviously, and then engaging with people such as yourself to really clarify it, because each one of those segments that you talked about, feature engineering as an example, that's a deep topic. In and of itself is a deep topic. So
Yeah.
a little bit of knowledge is dangerous, but at the same time, it hopefully leads you into a sense of, is this interesting for me? Is this suitable for me? Am I interested in getting into this? And as I said, I do believe there are roles in data science for people who are taking it from a business point of view, as well as from a technical point of view. So you don't need to be. It's not all things to everyone. You can be a little bit of both. So you've covered an enormous amount in a lot of time. I mean, it's kind of amazing you covered it within 56 minutes. But I encourage people to jump on our platform, to look for your courses, and to continue their own exploration of, is data science right for them, and is the Google Cloud machine learning certification aligned to their needs. And obviously, as I said, it's not going to happen. No one's going to snap their fingers and overnight become a Google Cloud machine learning engineer. But if you're interested in this fantastic voyage, which I believe, I mean, from obviously I'm not the domain expert you are, but if you look at the fantastic voyage you've gone through in your own career, you've seen probably the evolution of an entire industry in a matter of years. Yeah,
True.
yeah. So with that, thank you, Bhavuk. We will see you again on our, hopefully another one of these events, and definitely see you on courses online.
Thank you so much, Paul. It was my pleasure to present everyone.
Thank you.
Thank you. I'll speak soon.